7-1, day 1, multiplying monomials. Essential question. How do you determine if an expression is a monomial? All right, so there's quite a bit of vocab in this first lesson for chapter 7. So a constant is something that does not change. A monomial is one term, which I'll show a bunch of those on the next slide to give you examples of what a monomial is. Product of powers is like a shortcut when you are working with monomials. So, for example, it means that if you have x to the a power times x to the b power, meaning that your base is the same, all you have to do is add your exponents in order to simplify. Okay, power of a power means that you have an exponent and then another exponent. So when you have something raised to the a power and then also to the b power, you can simplify by multiplying your exponents, which would be the same as x to the a b. So you are multiplying your exponents. And last but not least, we have power of a product, meaning if we multiply two things and raise it to an exponent, that exponent gets distributed to everything inside of the parentheses. So you would take x to the a power and y to the a power. So you are distributing the exponent. Okay, now we're going to determine if a term is a monomial. You don't need to write the terms on the left. We will end up dragging them all over to these two columns. So you just need to write them once they're over on the right-hand side. So a monomial can be just a number. So write down number. A monomial can also be the product of a number and a variable. So really, a number is the same thing as a constant. So it can be a constant number or the product of a constant and one or more variables. Okay, so let me summarize that. So a constant is just like a number. So 3/4 and negative 530. Those are both constants. The 10xyz and the 8f to the 4th g, those are the product of a constant. So the constants are the 8 and the 10, and then one or more variable. All right, so not a monomial is when you have a fraction with a variable on the bottom, because you cannot divide by a variable if it's a monomial. This one is a little different, j to the negative third. We'll learn about this later in this chapter, but this is the same as 1 over j to the third. So that would count in that same group of not being able to divide by, I wrote monomial, I meant variable. You also cannot have any addition or subtraction in your problems. So, no adding or subtracting. It is not considered a monomial if you are adding or subtracting. So in summary, not a monomial means that you cannot have a variable on the bottom of your fraction, and you cannot have any addition or subtraction. Okay, here we go to the examples. All right, we are going to simplify the expression. And the thing with these problems, there is always two ways to solve them. One of them is going to be by writing it out, and one of them is going to be by doing the shortcut, which is what we learned in our vocab page, that power of a product. Those are shortcuts. So I'm going to, in the notes, do both ways, write down both ways. Then when you get to your homework, you can choose which way you want to do it. Okay, so b squared times b to the fifth. B squared is just b times b, and then b to the fifth would be writing it out 5 times. Then all you have to do is count how many b's we have. Well, we have 7, so b to the 7th is our answer. If I do the shortcut, this is referring to product of powers, where I have the same variable b, but with 2 different exponents, so we're going to add the exponents. So all I would have to do is take b and then add the 2 exponents, the 2 and the 5, and I would get b to the 7th. Okay, so then if I have x times x squared times x to the 7th, if I write it out, I have an x, I have 2 x's, and I have 7 x's. If I count how many total x's I have, it is 10. If I do the shortcut and I add my exponents, then I have, really it's x to the first for this one right here. If there's no exponent, it's 1. So if I add my 3 exponents, I have 1 plus 2 plus 7. So then I end up with x to the 10th. Okay, now we're going to get a little more complicated, and we have constants in front of our exponents and our variables. So if I have negative 6n to the third, that's the same as negative 6 times and then 3 n's. And then I have 2 and 2 n's. What I'm going to do is I'm going to multiply the negative 6 and then 2, which will give me negative 12. And then I have 5 n's, so n to the 5th. For the shortcut, I'm also multiplying negative 6 times 2, so that gives me my negative 12. And then I am adding my exponents, so I'm adding the 3 and the 2 to make 5. So if I put those 2 things together, I've got negative 12 n to the 5th. All right, same thing, 3px to the third. So 3 times, if it's just p, then remember that's just one of them, and then I have 3 x's. Keep in mind that the exponent just goes with the individual variable at this point. So that means 1p, 3 x's. And then on the bottom, I have 4 p's and 2 x's. Since I only have the one constant, the 3, it's just 3, I have 5 p's, and then I have 5 x's. For the shortcut, again, I have just the 3. For my p's, I have 1 plus 4. For my x's, I have 3 plus 2. So that will give me 3p to the 5th x to the 5th. So no matter which way I'm using, I should always be getting the same answer. You should never get a different answer from writing it out to the shortcut. Okay, one more like this. Now we have 3 monomials that we are multiplying. So I'm going to write out each one. So I have a 3, I have an x, and I have 4 y's, a -7, an x, and a y. And then this negative x squared y to the 3rd, I'm going to put a 1 in there. Don't have your variable be negative. Put a -1 there. And then have 2 x's and then 3 y's. So you should never be writing like -x times -x for the -x squared. All right, if I multiply all 3 of my constants, 3 times -7 is -21. -21 times -1 is 21. I have 4 x's and I have 8 y's, if I count them out. And the shortcut, 3 times -7 times -1 gives me a positive 21. If I add my x's, I have 1 plus 1 plus 2. So that would be x to the 4th. And then if I add my y's, I have 4 plus 1 plus 3. So I have 8. Put that all together and it is 21 x to the 4th, y to the 8th. All right, now we are going to move on to the next shortcut, which is power of a power. So you're going to see our monomial raised to an exponent and then parentheses and then another exponent on the outside. Okay, so you're always going to look at the outside exponent, and I see a 3. That means 4yz squared needs to get written 3 times. So 4yz squared, 4yz squared, 4yz squared. So if I take 4 times 4, I'm going to get 16. If I take 16 times 4, I'm going to get 64. So I have 64, y to the 3rd, z to the 6th. If I do the shortcut, what I am doing is I am distributing that 3 to everything that is inside of here. So what I'm going to do is I'm going to have 4 to the 3rd power, which I said is 64. Then I'm going to have y to the 3rd power, and then I'm going to have to the z to the 2 plus 3. So z to the 5th. Or sorry, not z, 2 plus 3, then we multiply our exponents. So z to the 2 times 3, which equals z to the 6. So then if I put all of that together, I get that 64 y to the third z to the sixth. So same thing as the other version, or the shortcut, or the red dot, excuse me. Okay, same thing. We look at our very outside exponent, which is 2. So I have to write this parenthesis out 2 times. So negative 2, 3 y's, and 2 z's. Negative 2, 3 y's, 2 z's. Negative 2 times negative 2 is 4. I have a total of 6 y's. I have a total of 4 z's. Shortcut, we are distributing this negative 2 to everything in our problem. So negative 2 squared is 4. Negative 2 times negative 2 is a positive 4. Y to the 3 times 2 is y to the 6th. Z to the 2 times 2 is z to the 4th. So then my answer is the same, 4y to the 6th. Z to the 4th. Okay, now we have 2 outside exponents for this one. So we have this 2 right here, and then we have this other 2 on the outside of that one. So what that means is we are going to look at the very outside 2 first. So this means that I have to write 5r to the third x squared twice. Okay, so then I'm going to take that and I'm going to write each one of these twice. So I'm going to write it 4 times total. So 5, 3 r's, and an x. So I'm writing that 4 times. Multiply all the 5s. 5 times 5 times 5 times 5 is 625. And then I have 3, 6, 9, 12 r's. And I have 4 x's. Okay, for the shortcut for this one, you are going to take your outside exponents and multiply them. So you will take both of these 2's and multiply them to make 4. So then you have 5r to the third x to the 4th power, and you are going to distribute the 4 to everything in the parentheses. So you have 5 to the 4th power, which is 625. You have r to the 3 times 4, which is r to the 12th, and then you have x to the 4th. So then again, the same